Hi and welcome to today's video. In today's video, we'll be looking at how to use the vector component method of vector addition. When using the vector component methods, we're going to follow a series of steps. Step 1 is to draw the vector component table. Now, what is the vector component table? We'll discuss that. After that, we calculate the resultant in X, which is Rx, calculate the resultant in Y, which is Ry. Then we use this formula R to get the resultant value, because here we'll be getting the resultant in X, the resultant in Y, but we have to get the actual resultant, which will be gotten by this formula. If we are asked to get the direction, we have to use tan theta is equal to Ry over Rx. Theta is the angle which gives the direction of the resultant. With that in mind, let's get into it. Okay, our question reads, the magnitude and direction of three vectors A, B, and C are as shown in the figure below. Our figure is here. Find the magnitude and direction of A plus B plus C. So that's the first part. Let's draw the vector component table. The vector component table looks like this. It contains in the first column, we have vector. Then here we'll split it into two columns where we have X component and Y component. Now, depending on the number of vectors, here we have three vectors, which is A, B, and C. So we have to partition three lines. A, that would be for B, and this one will be C. And the last row is going to be for the resultant. So vector A, vector B, vector C, and the resultant. Now the X component is like this. If we have AX, this is A cosine theta. That's how we get the X component. Next, the Y component is gotten by AY is equal to A sine theta, where theta is the angle between the positive x-axis and the vector itself. So all the angles have to be measured from the positive x-axis. So if it's the angle B, from the positive x-axis up to the angle, that's 45 degrees. For the angle A, we have to go from the positive x-axis all the way up to the vector itself. So that's 180 degrees, and so on and so forth. So let's get the X component, A cos theta. So our theta in this case we've determined is 180 degrees. Our A has been given as 190. X component is 190 cos 180. So that's what we put in here. 190 cos 180. Our Y component is 190 sine 180. So that's 190 sine 180. This goes on for B and for C. So to get the X component for B, this will be 200 cos, what's our theta? Our theta is 45 degrees. So that's 200 cos 45. And the Y component will be 200 sine 45. Lastly, for C, we go all the way like that. That's our vector C. Now this is from here all the way up to this part. That's 270. and we have 60 between that, so plus 60, that gives us 330. So our theta is 330, making our x component for C 150, which is here, 150 cos 330. Then our y component will be 150 sine 330. To calculate the resultant in x, resultant is the sum of all these terms. So that's a plus b plus c. But here we have to first calculate the resultant in x, then the resultant in y. This is the x component of the resultant is equal to x component of a plus x component of b plus x component of c. So it's now Rx. Rx will be here, and this is our Ry. Rx is equal to ax plus bx plus cx. Now, ax is 190 cos 180. So we say 190 cos 180 plus bx is 200 cos 45. Cx is 150 cos 330. This gives us, you can use your calculator here, 81.3. That's our Rx. So this is our Rx. We write it here. Rx is equal to 81.3. Next up, we have to get Ry. In a similar fashion, Ry is equal to ay plus by plus cy. Ay is 190 sine 180. 190 sine 180 plus our by is 200 sine 45. And our cy is 150 sine 330. Again, just make sure that your calculator is in degrees. This gives us 66.4. So this is our Ry. Let's write it here as well. Ry is equal to 66.4. Now we are done with the first three steps. We've gotten our Rx, we've gotten our Ry. Now to get the actual resultant, we have to use this formula. So we said R is equal to the square root of Rx squared plus Ry squared. This is equal to square root. Our Rx is 81.3 squared plus our Ry is 66.4 squared. 81.3 squared gives us 6609.69 plus 66.4 squared, that gives us 4408.96. This gives us square root of 11,018.65 and take the square root. This gives us 104.96. Let's round that to 97. So our resultant finally is 105 meters. Have we been asked to get the direction? Find the magnitude and direction. Yes, we have. So since we've been told to get direction, we have to use tan theta is equal to Ry over Rx. So tan theta, our Ry was 66.4, Rx was 81.3, 0.81672 tan theta. Get theta, we say theta is equal to tan inverse of 0.81672. Our theta is equal to 39.2 degrees. So that means that we are done with A. Now, since we already have our vector component table, B is asking us to find A minus B minus C. What that means is that when getting the resultant, instead of using Rx equals AX plus BX plus CX, it's now minus here and minus here. That will be the difference. Then we'll get our Rx and our Ry like that. So let's change things up. Our Rx in this case is now AX, which is 190 cos 180 minus 200 cos 45 minus our CX is 150 cos 330. This gives us negative 461.3. That's our Rx. Let's write it here. Rx equals negative 461.3. Ry is equal to AY minus BY minus CY. AY is 190 sine 180 minus 200 this gives us negative 66.4. So our Ry is equal to negative 66.4. Finally, the actual resultant, R is equal to the square root of Rx squared plus Ry squared. This gives us square root negative 461.3 squared plus negative 66.4 squared. That gives us square root of, this gives us 217,206.65. We take the square root of that. Our final resultant is 466.05 meters. Now, we were also told to find the direction as well. So, tan theta is equal to Ry over Rx. Ry in this case is negative 66.4. Rx is negative 461.3. Theta is equal to 8.19. Now, the last question, C. A fourth vector, D, which when added to these three vectors will give a resultant of 0. A fourth vector. Let's analyze what we're being told here. We want a fourth vector which when added will give 0. That means that they want the resultant to be 0, but we have to add a fourth vector. So this will be A plus B plus C plus a fourth vector D, which when added will give us a resultant of 0. Okay, resultant is equal to 0. What's our A? Now remember, we have to get AX, BX, CX, D. So our AX is 190 cos 180 plus our BX is 200 cos 45. Our CX is 150 cos 330 plus DX. This gives us 0 is equal to 81.3 plus dx. Now to get dx, we take 81.3 on the other side. It becomes negative 81.3 is equal to dx. We have to do the same thing for the y component. This becomes Ry is equal to ay plus by plus cy plus dy. Our resultant is 0. Ay is 190 sine 180 plus by is 200 sine 45, cy 150 sine 330, and we are looking for dy. All these here, this plus this plus this gives us 66.4 is equal to 0 plus dy. dy is therefore equal to negative 66.4. Now that we have this, we have to use the actual resultant, which is, in this case, it will be d is equal to square root of dx squared plus dy squared, so that our dx is negative 81.3 our dx and our dy 11018.65. 104.97, which is approximately equal to 105 meters.